All right, section 5.5, getting into adding and subtracting fractions. All right, we start with adding and subtracting like fractions, meaning fractions that already have a common denominator, right? And that's nice. We should know that in order to add and subtract fractions, the denominators have to be the same. So these are all working with ones that are already alike. So that'll be nice for us, and we will add and subtract algebraic fractions as well. And remember, those are fractions that have one or more variables. So with like fractions, right, we can simply add or subtract the values on the top, meaning this problem is really 5 plus 7 over 8, right? And so what I can do is add 5 and 7. That gives me 12 over 8. And I can reduce that. 4 goes in here 3 times, 4 goes in here twice. Or I could change that to a mixed number, which would be 1 and 1/2, right? 2 goes into 3 once with 1 left over. Now, number 2, we can look at this two different ways. We could turn it into an improper fraction, and that's the way we're going to do it if they are unlike fractions. But with like fractions, if you want, you could just add the whole number parts and add the fractional parts. The only confusing part is you have to remember to keep the negative in there. So, for example, -6 and -2 is -8, and the -3/4 and the -1/4 is -1, right? So my answer should be -9. Now let's look at changing them first, because that's the way we're going to do it when we get into unlike denominators, right? 6 times 4 is 24, plus 3 is 27. So there we have -27 over 4, plus here we have 2 times 4 is 8, plus 1 is 9, -9 over 4. Right? So really I have -27 plus -9 over 4. Now this goes back to when we learned our integer rules. So I have the same sign with addition, right? Meaning both of them are negative. So I can add these values together. 27 plus 9 is 36, right? And they're both negative, so that would be -36 over 4. And I know that that is equal to -9. Here, 19 is my common denominator. I have -17, +3. Right? Now, these are opposites, right? This is a -17, and this is a +3. So opposite signs we subtract. 17 minus 3 is 14. But the 17 is larger, so I have to keep that a negative sign, right? And that is -14 over 19, right? The other thing, remember we had our interactive number line. So I could say, all right, well, here's -17. Positive goes to the right, so -16, -15, -14, right? So when I add 3, I end up at -14. Now, with number 4, we have 8 as our common denominator, and then I have 7 minus 3. Now, we should all be able to do 7 minus 3, but just to relate it to our integer rules, remember, if we want to change it to an addition problem, I go leave this as 7, change to addition, and the opposite of 3 is -3. So now I can use my integer rules, which says a 7 positive and -3 are opposites, subtract. So 7 minus 3 is 4. 7 is bigger, so I leave that there. 4 over 8, should know that reduces to 1 over 2. Number 5, common denominator of 3. 2 minus negative 1, right? Minus negative. So this one definitely will help to change into addition, right? So leave it as 2, change opposite, right? Opposite of negative 1 is positive 1. So here we would have 2 plus 1, which is 3, over 3, right? So when I simplify there, I get positive 1. Now, number 6. Here we have a common denominator of 5, but on top we have 3 values. I have negative 4 plus negative 3 minus negative 1. So what I want to do is I want to start by going order of operations, right? And so addition, subtraction, whatever one comes first. So I'm going to do this first, negative 4 plus negative 3, right? So they are the same signs. So I'm going to add their values. That's 7, right? So when I combine negative 4 and negative 3, I get negative 7. Now I have negative 7 minus negative 1. So I have to go leave, change, opposite. So negative 7 plus 1 would be negative 6, and that is over 5, right? And I'm going to go this way. I'm running out of room there. Or, right, or I could write that as a mixed. 5 goes in there once, and this would be 1/5 remaining, and that value is negative, right? So either one of those would be okay. Now with algebraic fractions that have like denominators, same idea here. So I'm going to go 14, and then I have 3x plus 2x, right? And then since these are the same, right, both x's, I can say 3 plus 2 is 5x and 14. Got to be careful though, because make sure there's no reducing of the number part, right? 5 and 14 only have a common factor of 1, so I leave that there. Number 2, common denominator is 8. 1, right? Remember our coefficient there is 1 plus 3 is 4. So we get 4r over 8. And this one, notice, can be reduced to 1r over 2. Let me just show you some ways that this would be written. Since it's a 1 coefficient, r over 2 is the same thing. Or you'll even see it written as 1, and let me keep that sign the same. You'll see that written as 1/2 r. All three of these are the same exact thing. And it doesn't matter which way you put it. It's probably going to be in an answer key like this if that's the way you start off the problem. Now, if this is the way you start off the problem, where it's some a coefficient times the variable, it'll probably be written more like this, and I'll show you what I mean there. So these are just like terms, right? They're x variables. So I could either turn this into improper, right? So 3 times 1 is 3 plus 1 is 4. And that's really x over 1, so that'd go on top, and then this would be the same. Right, so then I would have 3 as the common denominator. 4x and 4x is 8x over 3. Or, right, that would be 2 and 2/3 x. Right, and if you look at it, 1 plus 1 is 2. 1/3 plus 1/3 is 2/3, and then you have your x variable. Either one of those is okay. Now, our evaluate problems. We haven't done these in a while, but this is review. Remember, we take the variable, put parenthesis around it, and then what I'm going to do is I'm just going to insert what x is. Right here, it's 12 over 13. Here, it's negative 2 over 13. Right, so my common denominator, and then I'm going to have 12 plus negative 2, right? Opposite sign, so I'm going to subtract 12 and 2, which gives me 10. 12's bigger, so it's positive 10 over 13. Here, right, be careful to leave that. So we have x minus y. So if I fill in x, right, we had 12 over 13. Y was negative 2 over 13. So common denominator is 13. And on top, we have 12 minus negative 2. Remember, we put the parentheses there because we have two signs in a row. So if we go leave, change, oops, I wanted to change that to a different color. Change that to addition, and then opposite of negative 2 is positive 2. So 12 plus 2 gives me 14 over 13, right? Or 1 and 1/13, right? 13 goes in there once, and there's 1 left over. Oops. So one more example here. So we have y minus x. So y goes first, which is negative 2 over 13. And x goes second, which is 12 over 13. Again, common denominator of 13, negative 2 minus 12. So subtraction, we're going to go leave, change, opposite. All right, so negative 2 and negative 12, same sign. All right, we add them. And we get negative 14 over 13, which would be negative 1 and 1/13. So, again, another short assignment for you. I'm hoping that you are practicing these problems so you see all the different types and make sure that you can do them on your own. All right, let me know if you have any questions. Have a great day, and we'll talk to you soon.